Okay, so in this video lecture, we're going to be going over the overhead joist example shown in the PowerPoint in class. Now, the first step, we have to open up ABAQUS. So just click on the ABAQUS CAE icon on your desktop, which should have popped up when you downloaded ABAQUS. Or you can just go to your Windows Start menu and find it. So this is the start display when you open up ABAQUS. So there are three options you can choose from. But in this class, we're just going to be working with the standard explicit model. So you can just double click on that and you'll get this window. So to create a part, you go to the Parts tab and just double click Parts. And you're going to get this pop-up window. So we could work with two different parts, 3D or 2D. But in this class, we're just going to be doing 2D. So click 2D planar. And the type is the deformable. And right now, for trusses and beams, we're going to be working with a wire frame. So for basic feature, click on wire. Now, as said in class, ABAQUS doesn't have units, so everything is just in base of numbers. So for approximate size, this is just setting the size of the grid that you're going to be drawing your part on. And if you remember from the overhead joist, the total length is about 2 meters and the height is 1 meter. So we'll just choose a size of 4 meters, which is a big enough grid to fit our part on. Your part cannot go off the grid, otherwise ABAQUS won't be able to read it. So click continue and your grid will pop up. Now, there's two ways that we can draw this part. You can either click the icon here to create lines, or you can see on the bottom, you can enter XY coordinates. So for this, we're just going to draw the lines and dimension each line. So just click and draw your overhead joist. And now we're going to dimension the part. So just click on that little tab there and add each dimension. And you can also set equality constraints. So we just clicked on that icon, equal length, and we're going to select every member. Just hold down Shift and click on everyone. And it's going to set every length equal. And now we have our truss. And click Done. And then click Done again. And now your part is fully created. So the next step, we need to assign a material for this part. So double click Materials. Now under General, you will see that you can actually input a density. This will be used later on in the class for when we're creating our final project. But for now, we're just going to leave it blank because it's not used for this problem. So thermal and electromagnetic, we're not going to be using in this class. So just go to Mechanical. And our part's going to be elastic, so go to elasticity, elastic, and click on that. And we can input our Young's modulus and our Poisson's ratio. So for this truss, we're just doing steel. So 200 e to the 9 and Poisson's ratio of 0.3. And click OK. So now we have our material properties defined. Now we need to create a section to assign this material property in an area to the entire structure. So there's three options to choose from: solid, shell, and beam. Right now we're working with trusses, so if you click on beam, you can then click on truss, and that is the section that we are creating. Continue, and now we can add a cross-sectional area to the entire section. So if we do the calculation, we had a 5 millimeter diameter, and this is equal to an area of 1.9635 e to the negative 5 meters squared. And click OK. And our material is defined. So now that we have created this section, we have to assign the section to the entire part. So if we click on Assembly and open up the tree, or we can just click on Assign here, we click Assign Section. Now we can either highlight all the members so that they're all selected, or we can select them individually with the Shift tab. Then click Done. And you'll see a thing pop up, and we called our section Section 1, and it's already clicked. So we can just click OK and assign this section to the entire part. And then click Done. So now our section has been assigned. So next we need to create an instance for the part. So if we open up the tree for assembly, there's instances. Double click Instances, and the whole part is already selected. And we're going to be creating an independent mesh on instance right now. Later on we will be using a mesh on part when we're making certain meshes, which we'll go over on later, for solid bodies. But for trusses, we're just doing independent mesh on instance. So apply and click OK. And we have created an independent mesh. Oh, we didn't select the actual part. Re-highlight. Apply. OK. Okay. Now that we have created our instance, we can create a step. Double-click step. Now there's a procedure type. For what we're doing right now, we're going to be doing linear perturbation. So click there. Linear perturbation. And a static linear perturbation is the type that we're doing for the truss assemblies. So continue. And you can put a description in there. I'm just going to leave it blank because it doesn't really matter. So now we can open up the steps and we can apply our boundary conditions and our loading conditions. So there's two tabs there. There's initial and step one. We want to apply initial boundary conditions to the structure. So we can open up the tree for under initial. So click the plus sign and you see BCs, those are boundary conditions. So double click that and we can create a boundary condition. Now symmetry / imagery is what initially highlighted, and that's for when if you're cutting a part that is symmetric, you can apply this to the nodes that you cut off. But for this, we're just doing a displacement rotation boundary condition for two nodes. So if we go back and look at the part on our PowerPoint, you can see at the bottom left there is a pin joint, and at the bottom right there's a roller joint. So if we go back to ABAQUS, so we already, now we need to select the node. So we right-click to create a boundary condition, and you can select multiple nodes at a time, but for this case, we're applying two separate boundary conditions. So we're selecting one node, and then you click Done. And you can now select what directions you want to apply to fix the part, to fix the node. So in this case, it's a pin joint, so that means it can't displace in the X or Y direction. So for the X direction, you click U1 to fix it. For the Y direction, we click U2 to fix it, and then click OK. And now we want to create another boundary condition for the bottom right node. So double click again to create another boundary condition, and click OK, continue, and select the bottom right node, and it'll be highlighted orange. So click Done. For this one, it's a roller joint, so it can roll in the X direction and it can rotate, so we only want to fix it in the Y direction, so we click U2 and click OK. So now we have set our boundary conditions. Next, we open up the tree next to step 1. And here we'll see loads. And now we can apply the loading condition on the truss. So there are many different options that you can select to apply a load. But in this case, and for most trusses, you're just doing a concentrated force at a certain node. So click concentrated force, continue. And now select the node that you want to apply the force. And then click Done. Now, you'll see CF1 and CF2. CF1 is just for an X direction, and CF2 is just for the Y direction. So in order to apply a load going down, you simply just apply negative. So for left or down, you just put a negative in front of the number, and we had a 10,000 Newton force. So put 10,000. Remember, make sure your units are consistent throughout the entire process. So OK. And we now have our load condition applied. So the next step is to create our mesh. So if we go to Module and down on the tab, we can click on Mesh. And if we go to the top, we click Mesh, and then we can select an element type. So we're going to define the element type we're using for each truss. It's going to be the same for this one, so we just highlight the whole structure and click Done. And now you'll see there's an element library and a geometric order. So we're doing a standard library with a linear order for trusses. So just click on truss. Some elements later in the class will be quadratic, but for now in the beginning, we're just going to use truss. And there will be a description at the bottom, and it says a 2D node, a 2-node linear 2D truss, and that's the element we are assigning to the truss, and click OK. And now we can click Done since we already selected all elements. Now we need to seed the part. So to seed the part, we're just defining really the number of elements per truss section. So if we go to seed, remember we created an instance earlier, instance, and you select the entire frame again. Done. Now we can approximate the global seed size for the part. So if you remember, each section was 1 meter long or 1 unit long. And we only want to have one element per section. So if we assign a global size of 1, it'll make one element per section, and it'll apply nodes at the actual node locations. So we clicked apply, and you can see it highlighted at the nodes where the seeds are. Now let's say we said 0.1 for the global size, and we clicked apply. You'll see that a bunch of nodes were actually applied throughout the member, but we just want one truss member per section, so we put approximate size of 1 apply, and click OK. So now we have seeded the part. And now we have to mesh the part. So we click on mesh, we mesh on instance, because we created an instance earlier. Later we'll be meshing on part when we do meshes on solid bodies, but for now we're just meshing on our instance that we created, so click done. Now we're ready to submit the job for analysis. So if we go to the bottom under analysis, you'll see jobs. Double click it, and you can create a job. You can edit the name of the job and click continue. We're just going to call it job 1. And now we open the tree now that the job is created. So now you'll see job 1, which is what we just created. So right click on job, and then we'll click submit to submit the part for analysis. This is just a warning saying we've already created a job called job 1, which is why you might want to change the name. But it's fine if we overwrite it for now, so we can click OK.
We accidentally forgot to
added
on instance, but we will do that right now.
We just have extra instances. Let's go back to mesh. Mesh on instance.
Highlight it.
No. Click done, yes. All right, now it's meshed. Right click, submit. We just had problems earlier assigning the instance. You shouldn't have any problem. All right, so now you'll see that it says job has been completed. So we can now analyze our results. So right click on job, click results, and now you'll see your structure. Now you can plot the deformed structure by clicking this button, or you can go to plot and click on deform shape here. So you have undeformed and deformed, and you click deformed and it'll show the plot. Now it kind of looks as what we expected since we applied a force right down the middle, but now we want to see what the actual, so we see the stresses, it gives you an S Mises in the box there. Now we can also change this to S11. We can see those stresses as well, or we can also change it to see the displacements. So if we go to report, we do field output, we can actually create a report of the results that we want. So if we click on the tree, we just want to see the stress components. Click on the tree, scroll to the bottom, click S11. So this is the stress that we want to analyze. So when we click apply, it'll create a report called ABAQUS.rpt, and you'll see it on the bottom. It'll say the field output report was appended to file ABAQUS.rpt. Now, in order to view this, you need to go to the folder where you have saved the file. So click OK, and we'll open up the folder that we saved the file. Now, to see where, you should actually do this in the beginning. You should set the work directory to where you want to save the file, and right now we have it at ctemp. You can click the folder icon to the right of that, and you can pick the folder that you actually want to save your file to. But this is just showing us where we actually saved our file. So cancel, and we'll go and view our RPT report. And that right there, that is called ABAQUS, and as you see, you'll say type, and it's an RPT file. And that is the actual, that is where our results were appended to. So if we open it up, you'll see there's actually a lot of results that have already been put here because a lot of simulations have been run under this name. And if you remember what it said in the dialog box is that the results were appended to this file. So it just keeps adding results to this file. And you can change the name and make different RPT reports, but we just kept adding to this one. So we scroll to the bottom to get our latest results. And as you can see here, it shows the stresses at all the elements that we have created. And we have about 294 is our highest stress on the truss members. And if we go to the PowerPoint and we scroll down, we had uploaded the results on the PowerPoint for you to see, so you can check to see if you get the same results. And here, this is just a screenshot of our results. So that will conclude the introductory ABAQUS lecture. Thank you.